There are n colors labeled from 1 to n. We have A1 balls of color 1, A2 balls of color 2, and so on. You need to store all of these balls in some boxes. But there are two rules. The first rule is that each box can contain a maximum of 2 balls. The second rule is that each box cannot contain 2 balls with the same color. Can you come up with a strategy and an expression to find out the minimum number of boxes required to store all of these balls? This puzzle appeared in a problem on Codeforces, which is a competitive programming website. Pause this video and try to come up with a strategy to solve this puzzle. I asked ChatGPT to solve this puzzle, but it kept on giving me obviously incorrect answers. So then I asked Aryan, who is among the top rated competitive programmer on Codeforces, to solve this puzzle. And here is a simple and elegant solution to the puzzle. Consider the color with the maximal number of balls and let's call the frequency as mx. It is clear that each of these balls will need to go into its own separate box. So we will create mx different boxes and place one ball in each of these boxes. Now, if we can fit the remaining balls by placing them one at a time in each of these boxes, then we would have solved that puzzle. But that is only possible if the remaining balls are less than or equal to the number of boxes that we have created. So we get this expression. But the remaining balls is nothing but total number of balls minus the maximal frequency balls. So we get an expression that if the ball that has the maximal frequency, if the frequency is greater than or equal to sum by 2, then the answer would be mx. That is, you will require at least and exactly mx balls to fit all the balls in these boxes. But what happens when the ball count of each color is strictly less than half of the total number of balls? And this is the part where you might have some algorithms, but you are doubtful about the proof of correctness of those algorithms. In this section, we'll see an algorithm whose proof will be immediately obvious to you. Let us think about what does this sum by 2 represent. If there were no rules, then this would have been the minimum number of boxes required to store these balls, because each box can contain 2 balls and we need to fit these many balls in these boxes. So let us create S by 2 empty boxes and place them in a line. Next, the algorithm goes as follows. You pick colors in any random order. Then you pick all the balls of that particular color and you start filling these balls one by one. So suppose if the first chosen color is green and it has frequency 2, you place one green ball over here and the second green ball over here. Then if the next chosen color is orange with frequency as 4, you place one orange ball over here, second orange ball over here, third orange ball over here. But if you run out of boxes, then you simply continue this ordering in a cyclic manner. So after this, you place an orange ball over here. Then the last orange ball goes over here. My claim is that with this strategy, you will never create 2 balls of the same color in the same box. And why is that claim true? Because if this ball and this ball have the same color, it means that at some particular color you started populating the balls, then you went to this box, this box, this box, this box, and then you finally came to this box again. That means that you completed this entire cycle to arrive at this box. But if you completed this entire cycle with just a single color, it means you traveled all the elements in the cycle, and the length of the cycle is s by 2, because these are exactly the total number of distinct boxes that we created. Therefore that means that whatever color is residing over here, it has frequency of at least s by 2, which is a contradiction because we had assumed that each color has frequency strictly less than s by 2. Therefore we can guarantee that if we follow the strategy of placing the balls one by one according to their color, we will never be able to complete a cycle, and therefore no box will contain two balls of the same color. Therefore the answer to the original puzzle is the maximum value of the maximum frequency and the sum by 2, where sum represents the total number of balls. And with this algorithm we can solve the original problem.